In this video, we discuss the applications of the centripetal force. In the previous video, we studied about the centripetal force, and now we study the applications of centripetal force, and that is circular motion of a car on a level road. Circular motion of a car. Circular motion of a car on a level road. So there is a curved path. There is a curved path, and the center of this circular path is R. Center of the curved part is O. And there is a car which moves on a curved path. Means there is a circular motion of a car. Circular motion, there is a car which is doing circular motion on a curved path. So its weight mg acting vertically downward. Its weight acting vertically downward, and the normal reaction acts on both the wheels. The normal reaction acts on the wheel. Is suppose R1 and R2. Opposite to the wheel. R1 and R2 with the normal reaction acting on the wheel of the car in a direction opposite to the weight, in a direction opposite to mg. And when the car turns in a circular path, the wheel tend to move. Both the wheels tend to move in outward direction, away from the center. When the car turns in circular path, the wheel of the car tend to move away from the center, and the centripetal force required to keep the motion is given by frictional force of friction. F1 is the force of friction acting on this wheel, and suppose F2 is the force of friction applied on the another wheel. And this force of friction balances the centripetal force. In a turn, the wheel of the car tend to move in outward direction. It tends to move away from the track, and therefore the centripetal force required is fulfilled by force of friction F1 and F2, which are acting on both the wheels, and the total normal reaction R is equals to R1 plus R2. Total normal reaction equals to R1 plus R2. So, when a car moves on a curved level road, when a car moves on a curved level road, when a car moves when a car moves on a curved level road, the force of friction between the road and tires, the force of friction, the force of friction between the roads and tires, the force of friction between road and tires provides necessary centripetal force, provides necessary centripetal force. When a car moves on a curved level road, this is a curved level road. So when a car moves on a curved level road, the force of friction between the road and tires, which is F1 and F2, provides necessary centripetal force because the wheel tend to move in outward direction. The wheel tend to move away from the track, away from the center of the circular path. So the necessary centripetal force is provided by the force of friction which are acting on both the tires. Provide necessary centripetal force required to keep the car in motion. Required to keep the car in motion. Required to keep the car in motion. And while taking the turn, the tires of the car tend to leave the road. While taking the turn, the tires, the wheels of the car tend to leave. While taking the turn, the wheels of the car tend to leave the road and go away. Tend to leave the road and go away from the center of the curve. Leave the road and go away from the center of the curve. And the force of friction F1 and F2 acts inward. Thus, force of friction F1 and F2 on the wheel acts inward. So while taking the turn, the wheels of the car, while taking the turn, when the car takes the turn, the wheels of the car tend to leave the road. The wheel of the car tend to leave the road and go away from the center of the curve. The tendency of the wheel to go away from the center of the curve and to leave the road. When the car takes the turn, when car takes turn, the tendency of the wheel to go away from the center of the curve and tend to leave the road means in opposite direction. In this direction, the force acts on the wheel and to keep the wheel in motion, to keep the car in motion, the force of friction F1 and F2 acts in inward direction. The tendency of the wheel to go outward direction and to overcome this force and to balance this force, the force of friction F1 and F2 acts in the inward direction. So the force of friction which are acting on the wheel F1 equals to mu into R1 and force of friction F2 equals to mu into R2, because we know that force of friction F equals to mu into R, where mu is the coefficient of friction between the road and tires, where mu is the coefficient of friction between the road and tires, between the road and tires. So F1 force of friction acting on the first wheel, F1 equals to mu into R1. R1 is the normal reaction, and force of friction F2 acting on the another wheel, F2 equals to mu into R2, and the total force of friction, equals to F1 plus F2, which is equals to mu R1 plus mu R2, and taking common we get mu into R1 plus R2. This is the total force of friction mu into R1 plus R2, and R1 plus R2 is equals to mg. R1 plus R2 normal reactions acting in upward direction and mg acting in downward direction. So total force of friction F1 plus F2 equals to mu into R1 plus R2 equals to mu into mg, because R1 plus R2 is equals to mg. So for the car to stay on the road, now for this is the total force of friction. Total force of friction equals to mu into R1 plus R2, and R1 plus R2 equals to mg. So this is equals to mu into mg. For the car to stay on the road, for the car to stay on the road, for the car to stay on the road, the maximum force of friction must be equal to or greater than, for the car to stay on the road, the total force of friction, the total force of friction must be greater than or equal to centripetal force. Centripetal force. For the car to stay on the road, for the car to stay on the road, the total force of friction, the value of the total force of friction, the magnitude of total force of friction must be greater than or equal to centripetal force. So the total force of friction already we have calculated, which is equals to mu into mg, and this must be either greater than or equal to the centripetal force, and centripetal force is given by mv square by r. So from both sides m gets cancelled, and mu rg is greater than equals to v square, and v square should be less than equals to mu rg. The value of v square should be less than equals to mu rg. So the maximum speed, with which the car turns safely, the maximum speed with which the car turns safely in a curved road, v square is less than equals to mu into r into g, and v should be less than equals to under root of mu rg. So this is the maximum speed of the car. This is the maximum speed of the car, maximum speed with which the car turns safely on a curved level road. Maximum speed with which the car turns safely on a curved level road. So it is also written as V maximum. Maximum speed of the car to turn safely on a curved level road. So see once again, circular motion of a car on a level road. When a car moves on a curved road, the force of friction, when a car moves on a curved level road, the force of friction between road and tires, the force of friction between road and tires provides necessary centripetal force required to keep the car in motion. And while taking the turn, the wheels of the car tend to leave the road. While taking the turn, the wheels of the car tend to leave the road and go away from the center of the curve. from the center of the curve, and thus force of friction F1 and F2 acts on the wheel in inward direction. The force of friction F1 and F2 acts on both the wheels in inward direction. So F1 force of friction is given by mu into R1. R1 is the normal direction acting on this wheel, and R2 is the normal direction acting on the other wheel. So F1 equals to mu into R1 and F2 equals to mu into R2. These are the force of friction acting on the wheel, and total force of friction is found by adding F1 and F2. So total force of friction equals to F1 plus F2 equals to mu into R1 plus mu into R2. Taking mu as common, we get R1 plus R2, and R1 plus R2 is equals to mg. Total upward force equals to total downward force. So this is the total force of friction. Now, for the car to stay on the road, the total force of friction must be greater than or equal to the centripetal force. For the car to stay on the road safely, the total force of friction must be greater than or equal to centripetal force. So the total force of friction mu mg should be greater than equal to mv square by r, and from both sides m gets cancelled, and we get mu rg is greater than equals to v square, and v square is less than equals to mu rg. And the maximum speed with which the car turns safely, the maximum speed of the car with which it turns safely, v square, is less than equals to mu rg, and v maximum is less than equals to mu rg, where r is the radius of the circular track, and g is the acceleration due to gravity, and mu is the coefficient of friction. And if the speed exceeds v maximum, the car will skid. If the speed of car exceeds v maximum, then car will skid. If the speed of the car gets increases, if the speed of the car becomes more than the maximum speed, more than v maximum, then the car will skid and go off the road, and go off the road, and go off the road. If the speed of the car exceeds v maximum, then the car will skid and go off the road in a circle of radius. Go off the road in a circle of radius greater than r. Greater than r. If the speed of the car increases by v maximum, if the speed of the car increases by v maximum, then in that case the car will skid and go off the road in a circle of radius greater than r. So the maximum safe speed depends on the radius and the coefficient of friction. The maximum safe speed v maximum depends on the radius of the curved path and coefficient of friction between the road and the tire. The maximum safe speed. The maximum safe speed of the car depends. The maximum safe speed of the car depends on the radius of the curve path and the coefficient of friction friction between the road and tires. So this is the expression for maximum speed of a car on a curved level road. V maximum should be less than equals to mu rg, and the maximum speed of the car depends on the coefficient of friction mu and also a radius of the circular curve r. And if the speed of the car exceeds v maximum, then car will skid and go off the road in a circle of radius greater than r.